hear me? Because if not, I have to replace my microphone. Nice. Okay. So this is a presentation for me, my company Magix, National Instruments. We all know National Instruments. I'm Josef Eiswirt. I'm the general sales manager, so the head of sales of our company. So still a LabVIEW CLA. I started my career as a LabVIEW developer in a company called NIWeek. It's a small engineering company from Germany, and we have to focus on test rig optimization, test rig development. So I had a focus on optimization, and what I was really falling in love with was LabVIEW, and using LabVIEW as a tool to optimize big test rigs that are not so common, so typical. So for example, the last big test rig I have implemented the software for was an end-of-line test rig for heating systems based on adsorption pump. So pretty crazy stuff. But currently, or today, I'm working for Magix GmbH, head of sales, still have my CLA, so I have still some technical knowledge, and what I'm trying to do is bringing my technical experience and my commercial experience just to one person or to the customers and help them to clarify projects really nice and good. What is Magix standing for? So our keynote, our main idea is obtain reliable measurement data. So this is one of our main tasks where we focus and tackle the task of writing nice LabVIEW code, building up test rigs to test a lot of good things, and having a good test rig is always something for creating good and valuable data. And this is the second part of our company. We are heading for test data management and test data management solutions. So Magix is the worldwide biggest DRDM partner, largest DRDM partner from National Instruments, and we made a lot of good projects. So for example, last year you heard about, maybe in the keynote, about the DEUTZ project, where Dr. Röbel from Germany DEUTZ presented our test data management solution that increased the efficiency of developing new diesel engines in the heavy duty area. So we are located in Germany, the three German cities. This is Mönchengladbach. I didn't know any guy in USA who can pronounce it. So Mönchengladbach or M-Town, Aachen and Ludwigsburg. But everything in Germany, today we have a partner company here, also located in the expo, not near the ADAS IIT booth, Viviota. Viviota is taking care for the test data management here in the United States and in the APAC area as well. I mentioned it, ADAS IIT. ADAS IIT is a cluster of 4 companies, Conrad, SET, SEA, and Magix. And what we are doing is we're taking care for the challenge of sensor fusion in the application of advanced the ADAS, so autonomous driving and advanced driver assistance systems. So currently, what we figured out, there is no one-stop solution where you can buy or easily build up with one partner a solution for developing or engineering a sensor fusion model. For example, where I compare LiDAR, radar, V2X communication in just one test rig to increase the development speed of these systems. And these 4 companies, all National Instruments Alliance partners, are grouped up to a team to help Tier 1 supplier or even our OEMs to develop solutions, test rigs for the challenge of sensor fusion. And Magix is taking care of the part of the data management. So we're bringing all data there together. Yes, this is what we have here, and we have a really nice looking ADAS booth at the exhibition as well. So please come and visit us. The Viviota booth is next to it as well. So our topic today: live published the latecomer, product migration to LabVIEW NXG. So why did we do this? This was the first question of my CEO when I told him that we should try to migrate one of our products to the new LabVIEW NXG. I will come to this question a bit later. First, I want to show you the application. So This we're showing a product migration. So we developed a software that is used in a special application. Here you can see one, I like this picture, it's a really impressive one really good picture. These are turbines for power plants, so steam-driven turbines for power plant solution. And these, you can maybe imagine that these turbines are really heavy. And they're rotating quite fast, steam-driven. And if such a turbine starts to shake or starts to not run smoothly, bad things can happen. So what they are doing is, on these turbines, there is one special line, so a run-out line. This line is needed to be really accurate and is measured all the time during the process in a power plant. So then, if this shaft starts to shake inside of such a turbine housing, the power plant will be shut down. So during the process of manufacturing or even repairing such a shaft, it is really important to know how the run-out line, the quality of the run-out line. So at the end of the day, the manufacturers at a shaft likes to have a so-called run-out error of less than 1 micrometer. I know this is, I asked our United States sales guy, what is it in inch? He couldn't tell it so quickly, so I keep it on micrometer, but I think it's really small. Does anybody know what is an inch? No, I don't know. Okay. So the idea was that during the production or even the repair process, these run-out lane has to be measured really accurately and really fast, because they have no time to do long terms of application the sensor and so on. And they asked Magics to build hardware and software to measure this run out in a really accurate and a really fast way. So building such a turbine in a power plant and adjusting the run out sensor takes 2 days. And they were asking for us to build up a measurement system with the same accuracy that can be applied to the run out and do the measurement and with less than 12 minutes. So a nice challenge. We built this run out measurement system in 2005. The first version was made 2005, and we started with LabVIEW 7. So the oldest or the last version was made in LabVIEW 2016. So as you can imagine, started 2005, different iteration. There had a lot of different LabVIEW developers put their imagination, their style on it. So it's a grown application over years. What we built in is LabVIEW, DeckMX, and some Magic's toolbox, like we have some translation tools and so on, built up in DLLs and built up in LabVIEW libraries. We only use easy to use National Instruments hardware, so a USB 6251, so nothing too fancy, because we all know that LabVIEW NXG doesn't support all kinds of different hardware currently. Today we have more than 25 customers, and over 40 of these systems are in the field. So now we're coming to the point why I took this application. This was the old one. You can see it's really 2005 style. An old application that is in use. A lot of people are still asking for it. It's a well-known application, and it's not too complex. And what we wanted to figure out is how easy is it to do a complete product migration to LabVIEW NXG. LabVIEW NXG has a lot of good and new features we would like to use, but we wasn't sure if we took one of our more complex products, for example, products that are used in a car and is connecting to a CAN logger, to compact rear systems, if this migration will work really nice, or do we have to tackle problems we're currently not able to see? So we took a product that has a USB-driven or an iUSB card, so something we can really good handle. No other hardware, and you can see the complexity. So 450 VIs, 650 structures, and the last value is someone I really love. This was safe for me to convert 3.4 miles of wire. I don't know if you know, there is a small VI or tool, you can find it on the LabVIEW webpage as well, where you can measure the length of your wire inside of your LabVIEW code. And I love this value because it shows how much effort you have done. But still, it is a small application, a well-known one. A lot of customers love the new features, and we wanted just to try out what does it mean to change such an application, bring it to LabVIEW NXG, and add some new features. For example, the web VIs or something like this. As you can see, it's maybe, I call it a pretty typical grown source code. You see a lot of different or custom VIs and a lot of structures. The design of implementing like this is maybe not the best pattern you would do today. It's not best practice. But you have to know it started in 2005, and not all functionalities we know today wasn't available at this time. So just again, what we wanted to do in this kind of project, we wanted to getting in touch with NXG. So finding out what kind of problems might occur, what good features do we have, and what do we have to calculate if a customer asks for a migration, and we need to help them. And new features like web VIs or the SystemLink Cloud were really, really interesting for other projects, so we wanted to test it in an internal project without having the pressure of a customer in our way. So let's start with the first result. We asked one of our new developers, he started beginning of this year in our company, and the first thing I told him is, okay, take this VI and take this project and try what the conversion utility tool for National Instruments will do. And the first thing he figured out is, okay, I get a lot of error codes. The reason is, lots of property nodes are currently cannot be handled by the NXG because these functionalities are not available anymore, or are not currently available. I'm not sure what points will be implemented maybe later or will remove completely, but he figured out that a lot of our internal libraries could not be converted, and even some of the current things like property nodes for controls are not available. And so you're getting a good looking error list, so you can really jump in each VI and change or fix the problem, but the system gives you a lot of messages you have to handle if you like to using this conversion tool or like to do the migration completely automatically. What also is not a point that not works really nice to us, it doesn't support the folder hierarchy. So if you have an old program where the folder hierarchy is part of the structuring of your VIs, you're losing this information and you're getting a lot of flat code that is not maybe or losing information in this point. But what is really useful was converting single VIs, maybe with a low or high complexity. Okay. And there was some really nice point, I didn't know it, but he told me. Hidden gems, for example. Using the conversion tool even allowed us access to nodes and VIs we currently cannot find in the default NXG palette. So, for example, the in-place element structure, this is an element, I love it, so if it came out, it was really great for me because it helped to clean up my code. But it wasn't available currently in the current NXG version 2.0 here was used. But using the conversion tool for National Instruments directly created an VI where the in-place element structure was placed, and so you can reuse it in different VIs. And I think there was 5 or 6 of these hidden games. He called it Easter eggs, but I like the word hidden games. That we figured out, and it was really nice to know. So I think there will be a lot of elements or nodes and structures we currently know from the current LabVIEW version that are not available in the palette today, but but maybe in the future, because in the conversion tool it's already be addressed correctly. Okay, so what do we figure out? So trying to do the complete product migration by just clicking on the conversion tool and say do the job doesn't work for us, because we have so much property nodes and so on that are not supported anymore. And so the idea was, okay, if we cannot use the conversion tool, let's do it from scratch on. Yeah. And use really the complete NXG IDE as it is. Don't try to migrate single VIs. And you at the beginning you saw the complexity, like 3.5 miles of wire and 450 VIs over 9,000 nodes. And the new guy in our company, so started at the beginning of this year, certified LabVIEW developer with approximately 3 years of experience in basic LabVIEW. So he didn't see any kind of NXG before. I think this is something you need to know to understand the next number. The overall development in NXG took 20 days. So he started the project, he tried the conversion, he failed, but it's okay because it was a test. And we told him, okay, take your time, do the complete migration by look at the old code and build it from scratch on. So he removed a lot of bugs and old handicap structures and did a really nice job. So 20 days for a complete product that was developed over years. I like it. And here are some highlights. I don't know, who of you are using or already used LabVIEW NXG? Okay, not so much. So there's a complete new IDE. It reminds me a bit of Visual Studio. I like it because it's much more integrated. So you can much easier find the elements and put them in the right place, or it remembers you, for example, if you place an element on the block diagram that you have to replace the corresponding element on the front panel, and it directly gives you this element to your mouse pointer, and not just dropping it anywhere and you have to search for it. I don't like this, but the new feature I like it much more. And one of the things that wasn't available in the default LabVIEW, and now is available in LabVIEW NXG is, for example, the System Designer. The System Designer gives you a really nice overview how the structure of your complete system looks like. So in our case, we just have a PC in the middle and connected by USB a multifunctional I/O device from National Instruments. Pretty simple, I know. On the left-hand side, you still have a web server because we like to play around with the web VIs and the SystemLink Cloud. But as you can imagine, if you have a more complex system, like we try to use, for example, NXG in an automotive application, where we are connecting to different Compact Rio and IPXI and the CAN bus, such a system designer can help you to figure out where are my connections going, where are my devices, and how are my devices should be connected, and if they are all alive. So I can here directly see, for example, if a device is connected and ready to use. So a really nice thing that helps you to design your system and to understand how the different components are connected to each other. What I really like as well is new functionality that helps you to clean up your code. So I think this is a structure everybody of us knows. Like, okay, I have here a cluster with different elements, and I like to change the value of an element inside of my cluster, or just getting the value out of my cluster. Yeah, bundle, unbundle default elements. Today it just looks nicely, and using the properties to changing the values of the cluster or the values inside of the element in the cluster is just smaller, more compact, more directly. It our time remembers me a bit on LabVIEW classes, but yeah. Another point where we're not sure, so here in this case we only have DACM-X VIs, so we don't have different hardware or CAN bus or so. And the question was, okay, how is a polymorphic VI like the DACM-X behaving under the new LabVIEW NXG? Is it still be easy to configure? The answer is yes. So it looks different. Now we have just DACM-X, not this selection terminal anymore. But if I'm clicking on the DACM-X read icon, I can directly change my parameters as I know maybe from this DACM-X if I'm changing here the polymorphic terminal. Not falling. Don't look good on the video. Okay. Some new elements was added, for example, the data grid. This is a functionality a lot of people who are used to program, for example, with the Visual Studio knows, was missing in LabVIEW. The data grid, a nice control that allows you to combine different data types in one smooth-looking control element. So, for example, here I can put strings, numerics, checkboxes, LEDs, enums just in one column and use it as one element. I didn't know if you ever tried to build such a control in a normal LabVIEW. A lot of us tried it, for example, as an X control. X control are not supported anymore in NXG. This is what I heard. Maybe I'm old, but I didn't know them. Writing this as an X control can take 20 days, and this was the complete amount the migration took. So this was really an element where even the guys in our company who don't love NXG were really surprised, and they all like it because it allows you to define configuration dialogues in a really smooth and easy way. Later we will see this dialogue. Localization, good point. So I tell you, this software, this product is used worldwide, and so localization is a task we normally always have to do. And in this case, we tried the new localization. So if you're placing a control on VI, you can have a preview for the language and define different localization or different strings, depends on the language. The preview function works really nice. So you can directly see, for example, if the localized spelling is not, for example, too long. This was a big issue if translating to different languages. So Germany, I don't know if you know, but we love to concatenate words. Yeah. So if it's in the United States, maybe 1 or 2 words, in Germany it might be this long. Because engineers love to concatenate words in Germany. It's really interesting. What is not so nice, we will see it later as well, is it's not so intuitive currently to select the language during the not deployment process, but during the creation of the executable or the installer. So this is something that has to be or needs to be improved, or this is something we already feedback to NI. And what was not so fancy, that is, you cannot easily export all used localization strings to one big XML file or text file and give it to an office to do the translation work for you. This was something normally everybody who does localization normally does by VI scripting. So you're running through all your labels, maybe, I don't know, checked by a hashtag or a sign that is not visible, and you have exporting your labels, your visible labels, to a file, give it to a translation office, and getting the results back and just place it in another file. I don't know why, but the guys told me that this is not so easy anymore. The information are stored, but you cannot go by the Eiswirting and figure out all layouts. They told me that some elements or some controls that are hidden do not do the export job correctly. So be aware. I think this is just a minor problem that can be fixed in the next years easily or next iterations. But keep in mind, a preview during the development process helps a lot to see a problem coming up even before creating the executable. So, web panel, great. I love web panel. An easy way to just publish the information of a running BI during a web browser. So, in this case, the web panel is now, it's not a showstopper, but we like to play around with it because we had a lot of customers that were asking for it to do a migration to NXG because of the web panel. So we wanted to try it out. Currently, one user is using, or one of our customers is using this web panel just because he has, the camshaft can be more than 50 meters and have a diameter of more than a half meter. Don't ask me what is an inch. But really tall, and if you are on the diff or the other side of the shaft, sometimes you cannot see the laptop anymore. So what they did is just hang up two big monitors to the big television and calling this web page, and they can see the results really easily. So I know it can be done different, but we wanted to do it in NXG to get a feeling for it. And this is something that works really, really nice. Even because you don't need a Silverlight or another player on the web browser side where you are launching the NXG code. Sorry, the WebVI. Here you can see the NXG source code for sending the values we currently see in the WebVI to the SystemLink Cloud. So we are using here a SystemLink Cloud where this WebVI is hosted, and by using the SkyText we can send these information like runout error, position of the shaft directly by just defining the SkyText, SkyText, and sending the values to them here in a loop. So pretty easy, pretty directly. So no big thing. So I talked about a lot of the changes, but after 20 days and from the sales department, I wanted to see what is new, what is there. So here you can see a picture from the measuring device. It's normally built up in a size where you can directly plug it in to a big mounting rack. So here are the sensors connected as well. We have 4 different kinds of sensors you can adjust. But this is a principal schematic picture. There, the shaft. The shaft will be rotated. You have to measure the rotation position, like 260 degrees. And you have different distance sensors that can measure the runout quality. So you see the runout error. And this is the first picture. So we changed the complete design. We have, for example, new shutdown icon added to give it a new and nice looking feeling. Still, yeah, cold and really engineering, like German engineering. So we don't have built up a fancy picture. So because the people who build up such camshafts are more like the traditional ones. They don't love to have pictures that are too colorful. Data recall, start measurements, easiest 2 buttons, and if you can see here, this is how the graphical user interface changed. So this is on the left-hand side, the old software, where we have traditional elements. Everything works pretty nice since years. On the right-hand side, you see the clean-up version. For example, with the data grid elements here, where it was much easier, much faster to combine different kinds of data types in one big configuration element. And you see bigger buttons because now everything is more on a touch panel device. Not everything is controlled by hand anymore. Or you can see here all the application with the functional buttons, F, whatever. Yeah. So more pictures like the graphic. So during the test, you can see, for example, the runout here on the. I have to put the wires on the tripping. You can here see, for example, the error of the runout measured over or displayed in a polar plot, and here on an angle in a linear plot. In this old software, there was a way to show the polar plot as well, but you was able to show a smaller polar plot at the same time. Here we can see the polar plot. So everything looks much lighter, so it's not so crowded with different elements. It looks younger, fresher. I like it. So from the perspective of the salesman, it's really much easier to sell right now. And again, a data recall. Data recall is just if you like to call an old measurement to see if there was maybe a change between two different repairing steps of the shaft. It's much easier by using a data grid where you can store the different information, and by just clicking on one file, directly calling the TDM file where this information are stored. Here in the software, you have to add, for example, a date, looking for the data, and then creating a report. New report functions are also available, and in this case, it was really nice to just have one button and creating an now I'm losing my voice. Creating an HTML report. So at the beginning, we just made, for example, it was really hard. We created a web page with the old version as well, and then printed it by default print as a PDF. It took, I asked our developer guys, I think 6 days until the report was finally done, because as you remember, in the default LabVIEW, you have sometimes to place all elements with nodes, putting the data in, maybe needing some nodes to disable some elements, and then you can print your front panel. In the new model, you can, or in NXG, you can easily create an HTML page by, for example, including JSON or something else. Yeah. This is a report web panel that is already shown. So by clicking on the report button, such panel will be created, and then you can easily print it by any PDF printer as you like. So, what is the summary today? A lot of elements we are currently using in LabVIEW development process are not available, or not available in a way we are currently are comfortable to use. So, for example, manipulating controls and indicators are not so powerful as we know it from a default LabVIEW. Property nodes in a way, and are not available anymore. Let's say it like this, or X controls are not available anymore. And the design of a lot of icons have changed. So if you'd like to do a direct migration, be aware that maybe the design layout, by just placing a control and it has a special size or special functionality, doesn't work anymore. I will show you an example. Like here. In old software, we have these tank controls, and what we made was we started filling this tank control from the middle. Depends on the error the runout measurement system measures. So if the error is, for example, here a bit about 100, the tank goes up to 100. If it's like below, so there's like a pit or a hole in the shaft, in the runout, then you get lower than 0. So this is just 0, it's a relative reference, and then you can see where the weak spot on the runout is moving on. And what we tried is to build this element because the customer loves them in NXG. And in an old application, you had just one tank. You couldn't define the minimum and the maximum and say, okay, begin from 0 and go up. LabVIEW NXG, it isn't possible anymore. You cannot go from the middle and go up or down. You have always to start from 0 and go up or go down, but it cannot go in the middle. So to keeping this tank control functionality, we had to combine 3 tank elements at the end of the day. So one just for the design, so that it looks good, so it's more as a frame. And then 2 that can start filling from the bottom or start filling from the top. And by small LabVIEW or bit of source code, you can imagine how we can now fill it from the middle. But this was something, for example, we didn't expect, that a tank control functionality, a default tank control functionality, wasn't available anymore. So, properties for manipulating controls, indicators are insufficient. I just showed it for tank control. It was one example. On WebVI, we don't have all controls currently. For example, the polar plot, that is really nice to show where the runout error is not available for the WebVI. It's only available for NXG. For different controls, there are the same restrictions. Description tutorials to manipulate NIWeek controls, missing. It works, but it has a lot to do with reverse engineering. I will show you one example in the next slides. The design of a lot of icons changed, as I mentioned before, so be aware if you like to keep the functionality and the customer knows it, it can take some effort to do. So we are talking about WebVIs and that maybe one step back. Why need CSS or JavaScript to edit WebVIs? WebVIs in default look not so nice. It can do it better maybe. So this is one of the default tank control WebVIs if you just place it. National Instrument or LabVIEW NXG generates a piece of Java code and HTML code that generates such a control. Yeah. If you like to optimize it, so make it look better, you can do it. You can directly access the Java code, for example, or the HTML code and edit it by writing Java or CSS. So this was the NXG web front panel without CSS, common style sheet. So it was a, sorry? Did I make okay, sorry. So this was a default block diagram as I showed before. And so we wrote a CSS where we added the style declaration we like to see on a customer's front end on the web page. For the web, or for the tank control, we even wrote JavaScript because depending on the filling level, we wanted to display a different color. So that if the filling level goes, for example, over a threshold of absolutely 200 or 300, it should be marked red. Until 300 or 400, I don't know the threshold correctly, but it should be more than 300. It is yellow, and below 100 or so, it is green. So to give not only the value, but also the possibility to have a direct color. It is possible, and you can do it by editing directly the JavaScript. But in this case, it was kind of reverse engineering because currently there's no documentation available, and so you have, for example, to open the web page that is generated from the WebVI, and then you can see how the tank filling is done. And if you know Java, you can edit it pretty nicely. So at the end of the day, we have nice looking WebVI generated, but you have to know it's not coming out of the box. So out of the box was the one picture before, where we see that the controls look like default controls. So, but you can do all the things you need to put your design needs to this layout by using HTML, CSS, or JavaScript. If you like to try it out, so once again, this WebVI is hosted on the SystemLink Cloud. So if you like to see this web panel or WebVI and seeing all controls, seeing how we have done the CSS and JavaScript, you can use these QR code and directly access the SystemLink Cloud and launching these WebVI with your default web browser. You did it? Does it work?
I point the camera on the thing and the web page comes up.
Cool, isn't it?
Yeah, I see it right there. SystemLink Cloud, I see the data.
Cool. Exactly. And the nice thing is, placing such a VI on the SystemLink Cloud, in this case, it was free of charge. So you can directly start a project in LabVIEW NXG, and if you are a registered user, you can directly ask for a SystemLink Cloud access. You will get a code. Please copy this code because I don't know how you can recover this code. So copy it or make a picture of it. And by using this code, you can directly use this code inside of your VI to publish the WebVI to the SystemLink Cloud. And then you're getting a URL where you can call this WebVI and everybody can have a look on your application. So please.
So if you now go back and edit the WebVI, you have to go back and edit the CSS and all that, or?
The question is how, if I can change it, how can we edit these WebVI?
Yeah, if you go back in NXG and
yes.
edit the WebVI and then create a panel out of it.
Yes.
You have to redo the CSS and all that.
Yes, exactly. The question is, if we changing something on the WebVI front, so for example, adding a new control or so, do we have to change the CSS and the JavaScript? So in part, yes. The CSS is more general, so it can adjust to the other elements as well. But for example, the JavaScript has to be implemented for each control separately. Yes. Maybe if you're a good JavaScript developer, you can write it in a more generic way. I cannot, and I even wrote this, so. Okay. So, sum up. So the question at the beginning was if we like to do a migration. It's a migration experience. So we tried it, and what was the conclusion of it? So using the conversion tool doesn't help us by having a big old, or what means old, a grown application that is really complex or have a lot of old structures. Not all features are available today, and if somebody asks me if we have to migrate an application that is not too complex, what should we do? Today, and this is really today, I would say make it from scratch. But what we also see is LabVIEW NXG is a really nice foundation and good basement for future development. So the right corner, or the corners are set correctly, so that new features, let's say like in-place element structure, today available but not directly in the palette, or something like LabVIEW's localization are there, and they have to be improved so that they are more usable in a daily business, but the right ideas are set. This is my impression from it. So I'm really happy to make this test, and I know that today, if a customer asks, you would say, no, it's still a sandbox, we are playing around, we can help you with small applications, to do big migration of an existing solution. We will wait what the next NXG 3.0 will bring. Okay, to this point, thank you. Do you have any questions? that I can answer.
That was 2.1 that you're saying is today.
So the software version we had used was 2.0 and 2.1. We tested both because 2.1 in our case wasn't stable in all cases or in all points. So sometimes we made a rollback to 2.0 to figure out where, if it's more maybe a point of installation or so, but it was 2.0 and 2.1, yes. Please?
In your experimenting, did you experiment with integrating code written in NXG with code written in the old LabVIEW? Is there any interoperability, or did you guys try and find any of those points?
The question was, did we have experience or did we try out to integrate old LabVIEW code to LabVIEW NXG, correct?
Well, so they were both running at the same time.
Both running at the same time. Okay. I don't know. No, it's a point where, because what I can say is we tried the conversion, and after the conversion doesn't run, we do the migration. This is a really nice point you're currently saying. We made a test for a customer because he wanted to have the new web APIs as well as part of their company information system for the test rig facility. And the software they're currently using is not, we don't even think about migrating it because there are so many dependencies, so many grown structures, so many different hardware components included, it will not work, we know. And in this case, we thought about bringing these two worlds together. So having the old LabVIEW application and just writing a new WebVI application that is linked. In a first test, it failed, but it was with LabVIEW NXG1. I don't know, but I can figure it out. I can ask our guys how maybe they did a second test with 2.1 and gave you feedback. Please.
Did you notice any difference in performance or resource utilization?
Okay, the question was,
Version.
okay, the question is, did we notice any difference in performance, memory utilization, and so on? And just repeating it because maybe not everyone here. Yes, so after creating an executable, it took less memory. What I think, or what we currently think is because we built a complete application from scratch on and using better and newer patterns. So a lot of old structures that are not best practice anymore are not reproduced. We only make the things we like to have. During the development process, we had a lot of problems with LabVIEW NXG 2.0 memory consumption by the IDE. So the IDE took a lot of memory and sometimes even crashed. 2.1 is much better, much faster. What we see is that the executables we create are a bit smaller, but we don't know if it depends on having just currently small VIs we're currently implementing NXG. You will see in the future. Do you have some problems with big executables, or where is it coming from?
No, just wondering, you know, since you're in a position to do kind of an A/B comparison between the two. So.
Yeah, okay. But for this, it was too small to say, okay, it is a 50 MB executable that consumes 600 MB of memory or so, and now it's less. No, it's so small, not really comparable at this point. Yeah. Any further questions? Please.
So it seems like you're one of the leading people in terms of having really played around with something that you've deployed and shared with customers in NXG. I think that's one for your time in this.
Yes.
Would you recommend migrating soon? Would you recommend trying to be on that leading edge, or would you recommend sort of going into the middle of the pack, or waiting as long as possible and going kicking and screaming? Is there a recommendation?
Good question. So the question, if I can summarize it, is do you recommend migration, or keep it on the track, or wait for a newer version or so? What I can say is we will wait until we start a new project in NXG, because currently not all features are available that we need to do our work. So from this point currently, high complex or edge application, from my point of view, cannot be done in NXG because the technology is not there. But in the future, and I hope it will be with NXG 3.0 or 4.0, we will start developing NXG in a much higher level, because new features like localization and web UIs are something the customers are really asking for. So for me, it's a value add that is really good to sell, and so I try to bring it to the customer, and yeah, our developer guys need to do. I hope this clarifies the question. So we played around today. Now today is still the sandbox. It's a tool to play, and I needs a lot of feedback to make the right decisions. So we're doing the job, helping him. This is part of the NI Alliance partnership as well. So what I think, so Platinum partner needs to help each other, but it's not for big projects today. Please.
Can we plug in code written in LabVIEW NXG into a prior code written in LabVIEW?
That was a similar question currently. So as I hear, yes, we tried it in 1.0 and 1.1, and that it failed in this case. We didn't try it in 2.0, 2.1 anymore, but this is a feature. In Germany, Lorenz Kasper is my main contact for LabVIEW NXG. He showed me that it works. Yeah, please.
To answer that question.
Oh, please.
In NXG, we have a group called AI interop node.
Yeah.
Using that node, you can execute PH, which are written in the version.
Oh, great. Okay. And it works, because we tried it for this one customer, but it was like, okay, here guy, you can spend 2.5 days, and after that we will check if it works or not. But if it works now,
You should be able to execute.
great.
But you need the RTE for that.
So you need to install the runtime engine of the old LabVIEW runtime code and the new LabVIEW NXG, and then you can run both systems in parallel. So you can call each other. Great, great to hear. Please.
So you mentioned some missing property nodes.
Yeah.
How did you end up working around that?
As you see, for example, in the tank control, we combine different we combine different tank controls to build a new one. And in some cases, you cannot work around like changing UI behavior. You have to change the workflow concept. This is something you have to know when you start, and this is the reason why I'm saying we cannot use it currently in big projects. For example, where hundreds of customers are using the software, and do not allow changing the workflow because they're using it, for example, since years. If you build something up from scratch, you didn't run into those limitations because it's natural limitations. It's something like you do not know that it's missing. Any further questions? Thank you all. I think there's still one. Again, commercials from National Instruments. You can rate. Thanks a lot. But I'm not Nick Butler. I think this is just the default one.